Good evening. Hope everybody's having a good Saturday. Finishing off our Thanksgiving break here. You can see Venus there at the top of the image. This was about 45 minutes ago, and just looking off to the southwest at the setting sun, and we've got a lot of mid-clouds today. And I'm going to go over that a little bit today, and I'll try to cover a little bit more of isotropic analysis. I'm going to try hard not to go into too much detail and kind of keep it simple, but I think you'll be able to walk away from this kind of picking up a few of the key points. So let's look at our picture across Texas, and I'll bring up my tool here. You can see that northerly flow that's in place across the state, a little bit of return flow back in Texas, but we're under this cool pattern, and it's being dominated by high pressure way off to the top of the map out in Missouri. And we're driving this tail end of the front all the way back to the Sierra Madre Oriental, I think, whatever that easternmost mountain is in Mexico, mountain range. So we're just kind of getting this cool flow from the east, basically. So the important thing to keep in mind is it's slightly cooler out to the northeast and warmer out to the southwest. And just a quick look elsewhere around the country. Pretty quiet most places. The west coast is under the influence of this Great Basin high. And looks kind of like a weak high, only about 10, 16 millibars. And we've got a little bit of cyclogenesis out in the northwest Pacific coast. But we do have a lot of weather in Southern California. Got the west winds coming onshore here. South winds out ahead of that. And we've basically got a front in place in the Mojave Desert region. And then looking out to the east, looks pretty quiet. Just high pressure, big old 1027 millibar high over Tennessee, blowing north wind out towards the Gulf. And then to the north of that, just kind of in between systems, getting a little bit of westerly flow. Back on the backside of this weather system in the Maritimes. And we're expecting the high pressure to move into that area a little bit later. So we'll go to the large scale picture. Yeah, why don't we bring up the upper level chart? We'll take a quick look at that. Get this centered here. There's the picture for right now. This is the 500 millibar heights and vorticity. So we can see we're dominated by, it's a little bit tricky, but we've got a planetary size long wave trough across the U.S. All right, and then superimposed on that, we've got these smaller scale patterns, like we got a ridge right there, got a trough here, got a ridge here, and a trough here, and a ridge here. And you can see the wavelength between each of these systems, and by wavelength I'm talking about the distance between this and this and this and that. That's kind of small, so we're talking mesoscale alpha. That's going to be in the realm of major shortwaves. So that's what these systems are. But the long wave pattern, that's going to be on the scale of thousands of miles. So we're talking about maybe a ridge there and a trough here and then a ridge here. So we've got a major trough along the California coast right there, kind of a major shortwave, and a little bit of jet stream energy right there. See that jet coming down the back side, getting a little bit of a jet streak through San Diego into the inland areas right there. So that's going to be an area of baroclinicity, possibly frontogenesis. Pretty quiet here in Texas, 20, 30 knot winds. Then on the east coast, there's that trough right there. Maybe a little bit of upward motion just offshore right there, supporting a little area of frontogenesis maybe in that area. And then looking very quickly at the surface charts, see if I can figure out where I put it. Yeah, here we go. This will be the structural analysis Looking at the air masses, you can see a very strong gradient of thickness right there. So that's suggesting cold front in Baja California up to the Arizona deserts, probably a warm front, something like that. Could be even further north like that. But anyway, yeah, this whole area here is baroclinic. So if you're in Phoenix or Tucson, you're probably seeing some rapidly changing weather right now. And then along the Rockies, the east side trough right there, high pressure across Tennessee and Kentucky right there. And things on the eastern U.S. pretty much dominated by that big high. So with that in mind, we can talk a little bit about isentropic analysis because we've got those clouds moving through. Let me see if I can bring that back on. Yeah, you see that right there. Now, the important thing is we're looking to the southwest. And you can see there's a very low cloud layer right there, little bits of clouds. They're moving left to right. So they're moving south to north, and those are about 2,000 feet above the ground. So in terms of millibars, that's going to be like maybe 925, 900. And then we've got this higher layer forming that overcast that you see there. That's up at about 8 to 11,000 feet, which is going to be about 750 to 650 millibars. And that's going to be important when we take a look at the soundings. And you can see that stuff is moving the other way. It's moving right to left. So that's going to be coming out of the west or maybe the west-northwest. So those directions are kind of important when we look at the charts. So let's go back and check out that chart. And I'm going to bring up the Fort Worth sounding. Okay, so let's see here. Who has northwest, west-northwest winds? Well, it looks like all these layers right here, pretty much the entire column up to the stratosphere. But the area in question that we're looking at is maybe in here. So that's going to be that broken layer that we saw in the time lapse. And we can see where the moisture comes close to the temperature line. That's going to outline an area of clouds right in here. Then what about that lower cloud layer? Just going south to north. Well, we're probably talking about something way down in here, like down here in the bottom of that sounding. So that's going to be in the 900 range, probably. So how do we analyze the flow isentropically? Well, we have to think in terms of isentropes because air that is kind of in a benign pattern like this, it's going to move, it's going to kind of follow the isentropes, which are surfaces of potential temperature. In other words, they're not going to move perfectly horizontally, maintaining 9,000 feet above the ground. They're going to actually vary slightly with altitude as they move. And they're going to, the surfaces that they follow are these lines right here. These are potential temperature lines. So if we have any downward motion, or air at, say, 675 millibars, it would basically follow a path kind of like that. Now, the isentrope that we're talking about intersecting that cloud layer, let's bring this down. In fact, let me bring up a different chart. I'm going to bring up digital atmosphere, and this is a program that I wrote a while back. Still working on it, though. So this is the latest sounding from Fort Worth. And you can see the heaviest cloud layer is going to be right in there because the lines are very close together. So what's the potential temperature in there? Well, that's pretty easy to do in digital atmosphere. We just follow this down to 1,000 millibars. That's going to be right there. And we get a temperature of 29 Celsius. Now, with isentropes, we do this weird thing where we have to change units. We have to go over to Kelvin, but that's pretty easy. We add 29 Celsius to 273 Kelvin. So that's going to be 302 Kelvin. So that right there, that's the 302 isentrope. So if you have a tool like PC or WinGrids, that's what I got here. There's not too many websites on the internet that let you deal with isentropic analysis. I don't really know why, but it's kind of this untapped void here. But I've got a script here for WinGrids, and I'm going to put in, see, I've got 302 Kelvin, and I'm going to plot the relative humidity, the wind, and the pressure. In other words, it's basically the height. And I'll just plot this real quick and let you see what it looks like. So we're seeing a 302 Kelvin isentropic analysis. And really all this is telling you is, see the white lines right there, the white lines in here? In fact, let me just simplify this. I'm going to plot just the height lines or the pressure lines. Okay, so this is pressure, which is basically a proxy for height. 700 millibars, that's going to be up about 10,000 feet. 780, that's going to be way down about 7,000. So when we're moving from here to here, we're ascending, we're getting higher in the atmosphere. And that's kind of the pattern we have right now. If I plot that 302 Kelvin isentropic analysis, you can see that's the flow we have in place. Air is flowing from lower to higher values. So we've got this ascent in here. And if we have a little bit of humidity with that, we're going to be able to squeeze out some altocumulus clouds out of that. And so that's happening in this area. Then on the backside, we've got isentropic subsidence. So this should be an area of mid-level clearing. So anyway, those are some things to think about right there. That's about as far as I wanted to go with that. And you can see above 14,000 feet, very dry air. And then we pick up this higher layer of cirrus and cirrostratus above that. And we can see that on the satellite chart. We can actually see two different layers here. This is infrared imagery taken about 15 minutes ago. You can see right in here, there's this area of patchy, kind of grayish cloud. This is going to be your stratocumulus and lower altocumulus. Then above that, we have this fibrous stuff that's a lot colder. That's going to be your cirrus. So we're basically seeing these two different cloud regimes that we were seeing on digital atmosphere here. The lower stuff here, and then the colored stuff higher up at about 25 to 35,000 feet. And this is all kind of subtly flow and lift approaching with the next system out to the west. Okay, looking out on chat and don't see any problems here really. Okay, so let's go ahead and go right into the forecast. Okay, so when you join us on tomorrow, Sunday tomorrow, we're going to be seeing some showers developing in Utah and Colorado with that lift coming in from the west. Probably a little bit of jet stream energy coming in. And then by the time our webcast starts, we're going to be looking like this. Cyclogenesis in the central plains there, and possibly a cold front coming out into the southern plains, kind of like that. So things are going to be changing quickly here. And normally we would plot maybe the warm front kind of like that, but we're seeing the thickness lines starting to kind of become a little more packed in this area. So maybe we're seeing a little bit of warm front development in Texas. And that could be augmenting some of this precip that the model is showing in Oklahoma and Kansas. And then further out to the west, we can see a lot of showers and mid-level cloudiness, precipitation, virga. This is probably going to be associated with lift with that jet stream and probably the cold core further back to the west. Maybe I can show you that cold core here. We'll run this up to Sunday evening. Yeah, so this is going to be an area of colder weather aloft, and that's going to be a very convectively unstable area. Enough to generate a few showers. So the thickness band is tightest in this area right here. So this is suggesting that front is pushing into Sonora and Chihuahua, Mexico, West Texas. Then, let's see, starting with the work week on Monday, looks like that system kicks to the east pretty quickly already in the Mississippi River Valley by afternoon on Monday. And there's that thickness band, so it looks like the front has already cleared Texas. Probably looking like that. And yeah, this looks like an area of warm frontal development, so maybe I'll put a front like that. And you can see that this area here is baroclinic, and the model is generating some high precip rates. It's going for 2 to 5/10 of an inch per hour. And let's see, we'll move forward to Tuesday. There's Tuesday evening. Looks like another shot of maybe... This is that weird trough feature I was talking about yesterday. I wasn't really sure what was causing that. Maybe kind of maybe a change in the slope of the front. That's about all I can figure, because the main front is going to be well to the south. So we're going to have a lot of warm air or cold air advection coming into the Great Plains. Should stay kind of mild or cool through the beginning of the week. Here's Wednesday. You can see a lot of the system has moved out into the eastern U.S. Not a whole lot going on in Texas itself. We're not getting a lot of cyclogenesis out to the southwest, so we're not seeing isentropic lift and clouds and showers developing in Texas, at least not yet. So do we have cyclogenesis here? Not yet. It's still weak, if anything. I mean, there is a low here, but we're not seeing very strong pressure falls yet. But there is warm air advection taking place in this part of Texas. So it is ripe for isentropic lift, for sure. All we need is maybe a little more moisture or a little stronger cyclogenesis to the west, and that would get stuff going in Texas. So here I would say there's probably at least a risk of clouds. Now we're starting to get a little bit of upslope flow as the flow turns more easterly on Friday morning. Looks like now we're getting some cyclogenesis out in Arizona. And now we're breaking out precip. So you see that right there. And the isobars very close together. So here's your southeasterly gradient. And I'll probably be going to San Antonio on that day, and it's probably going to be kind of cloudy for that drive. And, you know, if I do go to San Antonio next week, I will continue the webcast as usual. Should be kind of fun. Maybe I'll show a little bit of footage from that area. So Saturday, developing a lot of precip in Texas, and we've really got a lot of that cyclogenesis going on in Mexico there. And that system will probably slip south of the high-pressure area. You can see it going into the Gulf right there on Monday. And then we start looking to the northwest. You can see one little shot of cold air coming in, and pressures are really starting to build in western Canada here. And the models have been showing this for a few days now. So we're probably looking at a cold air outbreak around the second week of December. So here we are, 300 hours out. This is getting pretty far out, but this is staying pretty consistent with an Arctic outbreak into the central U.S. So it looks like it noses into Texas on the 10th, and then we start getting into some very finicky details here. It's hard to tell exactly what's going to happen after that. The GFS thinks the cold air mass, the cold air advection will kind of cease as we get new cyclogenesis out to the west. And after that, it's hard to say. I don't know. This is getting way out there, so I don't want to start picking at the details at this point here. Okay. I think that's probably going to be it for me for today, and hopefully we'll see you all tomorrow night, and enjoy the rest of your Thanksgiving weekend, and we'll see you tomorrow.